For you students, so far I explained what is a sequence, definition, what is limit of a sequence. When we say that sequence converges to L, that is of course L is called limit of the sequence. And what are monotonic sequences? Because using only definition of the sequence, limit of the sequence, it is not possible to verify whether it converges or diverges. So we have monotonic sequences and some theorems on that. Then Cauchy sequence and two theorems on limits of a sequence, and finally subsequences, and also I ended that topic with limit superior and limit inferior. That is one unit, sequences. You go through that topics that I have already covered, and if you have any difficulties you can free to ask. Now second unit for paper 1 is infinite series. First I define infinite series, then we consider the concept of convergence of infinite series. When we say that infinite series converges. Now what is infinite series? Let Un be a sequence. What do you mean by sequence? Sequence means it is a function from natural numbers to reals, and sequence is denoted by different notations. One method is we denote the sequence by its nth term, by writing the nth term. Example is Un is 1 upon n. This is the sequence. Un is n square is a sequence. Un is n plus 1 by n. It is a sequence. Un is a sequence given by 1 by n means what are the terms of the sequence? 1, 1 by 2, 1 by 3, 1 by 4, etc. And every sequence we consider here infinite sequence. Infinite means terms of the sequence are infinite. We are dealing with only infinite series, sequences. Now see the definition of a series. Suppose Un be a sequence, then the sum U1 plus U2 plus etc. U3 etc. plus Un plus so on, it is called a series. It is called infinite series. So if Un is a sequence, then U1 plus U2 plus Un plus etc. it is called a series. Now since it involves infinite number of terms, since this involves sum of the infinite terms, therefore the meaning itself has no meaning. Because how do you add infinite number of terms? Infinity, you know the meaning of infinity. Infinity means never ending. You cannot have the sum U1 plus U2 plus etc. up to infinity. Therefore, to have the meaning for this, that is U1 plus U2 plus Un etc. up to infinity, we introduce the convergence of this infinite series. Convergence of infinite series. For that, first I think definition is clear. What is that? If Un be a sequence, then U1 plus U2 plus U3 plus Un etc. infinity, it is called infinite series. And I explain or I give the meaning for this sum of infinite terms, introducing the convergence of infinite series. For that, we introduce sequence of partial sums. Again, sequence of partial sums. Suppose Sn is U1 plus U2 plus etc. plus Un. Suppose Sn be a sequence defined by U1 plus U2 plus Un. Then see S1, S2, S3, it forms a sequence. Suppose Sn is a sequence defined by U1 plus U2 plus Un. Then this is called sequence of partial sums. Understand clearly? We define Sn as U1 plus U2 plus Un. Then it is called sequence of partial sums. And if this sequence of partial sum converges, then we say that infinite terms converges, and that value of that for which it converges is called sum of the series. Of course, you have studied geometric series, a standard series, sum to infinity of that geometric series, and we discussed that also. I repeat again the definition here. Suppose un be a sequence, any sequence, then u1 plus u2 plus u3 un plus etc. to infinity is called a series, or more clearly infinite series. And this sum to infinite terms, this has no meaning because we have to add infinite number of terms. To give the meaning for this, we introduce convergence of this infinite series. When we say that infinite series converges, for that we form the sequence of partial sums. We consider u1 plus u2 plus un and denote this by Sn. Now Sn is a sequence defined by this. Sn is defined by u1 plus u2 plus un. Then this is called sequence of partial sums. Sequence of partial sums. And if this sequence Sn converges, then we say that infinite series converges. And that limit is called limit of the infinite series or sum of the infinite series. Now I take example to explain the meaning of this convergence of infinite series. Example, consider the series sigma 1 to infinity 1 upon n into n plus 1. So series is denoted by this sigma 1 to infinity 1 upon n into n plus 1. Now what is this? It is equal to 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4, 1 upon n is 4, 4 into 5, etc. to infinity. This goes up to infinity. Now this is the given series. What is the sequence? Sequence is 1 upon n into n plus 1. Now sum to, this is u1. What is u1? 1 upon 1 into 1 plus 2. u2, 1 upon 2 into 3. This is un. Correct? This is un. This is the sequence. Un is a sequence defined by 1 upon n into n plus 1. Now sum to infinity of this u1 plus u2 plus un is known as a series. If we take the sum, then it is called series. Now this series, consider this series. Now we verify whether it converge or diverge. For that we have to form a sequence of partial sums. What is the nth term? Nth term of the series is 1 upon n into n plus 1. So it is 1 upon n minus 1 upon n plus 1 by partial fractions. Therefore Sn, when do you say that series converges? If the sequence of partial sum converges, we say that series converges. Now what is sequence of partial sums? Sn is u1, u2, etc. un. This is Sn because this is u1, u2, etc. Usually series is denoted by simply sigma un. Even this 1 to infinity is not used. Only sigma un means summation un 1 to infinity. What is un here? 1 upon n minus 1 upon n plus 1. u1 plus u2 un is 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3 plus 1 upon 3 minus 1 upon 4. What is u3? Substitute 3. 1 upon 3 minus 1 upon 4, etc. 1 upon n minus 1 upon n plus 1. So what is this? 1 minus 1 upon n plus 1. Because these terms get cancelled. Finally, this also cancels with previous one. This remains, first term remains. 1 upon 1 plus n. Now limit Sn, n tends to infinity is therefore 1. Limit of this, what is this? Sn is sequence of partial sums and it is given by 1 upon 1 n plus 1. What is limit Sn? Limit Sn is 1. So what's your conclusion? The sequence of partial sum converges. Sequence of partial sum converges partial sums converges. Therefore, this given series converges. And what is sum of the given series? 1. That is the meaning of the series. How to define a series? If un is any sequence, then u1 plus u2 plus etc. infinity is called a series. When do you say that series converges? If the sequence of partial sums converges. Now I consider another series. Consider the series sigma n square. N is equal to 1 to infinity, of course. Usually only sigma n square is read. Now test the convergence of this series. When do you say that series converges? Series converges if the sequence of partial sum converges. It is I take sigma un. N is equal to 1 to infinity. This is our notation, sigma un. Now the sequence of partial sums Sn, how to define? u1 plus u2 plus etc. plus un. This is sequence of partial sums. Now what is u1? 1 square, 2 square, etc. n square. And we know that it is n into n plus 1 into 2n plus 1 upon 6. Now this is the sequence of partial sums. It is defined by this. N into n plus 1, 2n plus 1 by 6. Taking n is 1, 2, 3, etc. you will get terms of the sequences. You will get successive terms of the sequence. Now Sn, sequence of partial sums, is defined by this. Now take limit Sn. Now we find out limit of this sequence. N tends to infinity. It is infinite. Because see here, n tends to infinity, this becomes infinity. So what's your conclusion? The sequence of partial sums do not converge. It tends to infinity. Therefore, given series do not converge. Do not converge. Because a sequence of partial sum diverges. Therefore, the given series diverges. These examples are to convince the definition of convergence of a series. When do you say that series converges? If the sequence of partial sums converges, then we say that infinite series converges. What is the sequence of partial sums? Sn, it is usually denoted by, it is u1 plus u2 plus un. Sn is, nth term of that sequence of partial sums is Sn, it is u1 plus u2 plus un. Now one more example. Consider the series sigma minus 1 raised to n minus 1, n is 1 to infinity. It is sigma un. What is un here? Un is minus 1 raised to n minus 1. When do you say that sequence or this series converges? If the sequence of partial sum converges. What is the sequence of partial sums? Here, what is un? Minus 1 raised to n minus 1. Therefore, S1 is, what is Sn? Sn is, it is u1 plus u2 plus etc. plus un. Correct? S1 is u1. S2 is u1 plus u2. S3 is u1 plus u2 plus u3. And so on. S1 is 1. What is S2? S2 is u1 plus u2 here. Because Sn is defined like this. Understand definition? The terms that notations are very important. Sn is, what is Sn? Sequence of partial sums. How it is defined? Sn is defined as u1 plus u2 plus un. You know the un here. Un. Series is usually denoted by sigma un. This is un. S1 means u1. What is S2? u1 plus u2. u1 plus u2 is, what is u1? 1. What is u2? 2 means you have to take 2 minus 1. 0. Therefore S2 is 0. What is S3? Again 1. What is S4? 0. Because what is S4? u1 plus u2 plus u3 plus u4. This is S4. And what is u1? u1 is S1, 1. u2 is minus 1 because minus 1 raised to 2 minus 1. What is u3? Again plus 1. What is u4? u4 means minus 1. What is this? 0. Therefore, what is the sequence here? Sequence Sn, sequence of partial sums is first S1. Sn means S1, S2, S3, etc. Sn. Sequence is S1, S2, S3, etc. Sn. If we write the range of this sequence, then in terms of our notation, it becomes 1 0 1 0 1 0 etc. etc. This is the sequence of partial sums 1 0 1 0 1 0 and so on. Sequence means again it is sequence means infinite it is. We have to test the convergence of this sequence. For that we can use many concepts there. Monotonic sequences, alternating sequences and so on. Here not alternating, oscillating sequences and so on. 1 0 1 0 1 0 so on. Then what happens? Which oscillates. Therefore, the series, given series is also oscillating series. It is oscillates. I think definition of series is clear for all of you. What is the infinite series? When you say that the series converges. Now we consider some more concept here, because always it is not possible to form the sequence of partial sums. For that we have to have some different tests for convergence. 5 tests are there, important 5 tests for convergence. Using only this definition, it is not possible to test the convergence of given series. Why? Because sometimes it is not possible to have the sequence for the sequence of partial sums for the series. In that cases, we use different tests. Some 5 tests you are supposed to study. And also one more important thing is Cauchy's general principle of convergence. There we need not form the partial sums, sequence of partial sums. Now we study one by one, all that one by one. First important result is, if sigma un converges, then limit un is 0. Un is 0. If sigma un converges, limit un is 0. But converse is not true. What is the converse? If limit un is 0, then sigma un converges. This is not always true. First part is proof of this. First part. Let Sn be the sequence of partial sums. Sequence of partial sums of the series sigma un. Since first part, sigma un is convergent, limit Sn is 0, or sequence converges. When do you say that series converges? If the sequence of partial sum converges. Since the sigma un is convergent, the sequence of partial sums Sn converges. Say to S, it converges to S. Consider Sn minus 1. What is Sn minus 1? A subsequence of Sn. Sn minus 1 is a subsequence of Sn. It also converges, because every subsequence of a convergent sequence is convergent. Sn is also convergent and converges to same S. Therefore, Sn minus 1 converges to 0. Sn minus 1 converges to L minus L, because limit of an minus Bn is a minus b. that algebra of limits you have studied. S minus S, that is 0. But what is this Sn minus 1? Because Sn means converges to S. Limit Sn minus 1 is 0. And what is this Sn minus 1? Sn means it is u1 plus u2 plus etc. un. And Sn minus 1, un plus u2 etc. un minus 1. What is Sn minus 1? Limit un is 0. This is the first part. See the second part, converse is not true. Converse is, suppose limit un is 0. For that we use example here. Converse is not true. Not true. For that we take example. Let un is sigma un is sigma 1 upon n. Sigma 1 upon n. Therefore, limit un is limit 1 upon n is 0. N tends to infinity. But we prove that this series doesn't converge. Follow now? Sigma, what is the converse? Suppose limit un is 0, then sigma un converges. That is not true. I am going to prove that one. I have taken this example. Sigma un is sigma 1 upon n and the limit un is 0. But now what is the thing we have to prove now? We have to prove that sigma un, sigma 1 upon n doesn't converge. When, for that what we have to prove? When do you say that series converges? Sequence of partial sums converges. Now we prove that sequence of partial sums of this sigma un doesn't converge. Now Sn be sequence of partial sums. Sn is sequence of partial sums. Therefore it is Sn is what is Sn? Sn be the sequence of partial sums. Therefore Sn is u1 plus u2 plus etc. plus un. It is 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon n. Now I think you remember this one. Using Cauchy's criteria, we have proved that this doesn't converge. What do we have to prove now? We have to prove that if limit un is 0, then sigma un need not converge. When do you say that sigma un converge? If sequence of partial sum converge. What is the sequence of partial sum? Sn. Sn is the sequence of partial sum. How it is defined? Sn is defined by u1 plus u2 plus un. Therefore this is Sn. Now we prove that this doesn't converge because we prove that it is not a Cauchy sequence. Every Cauchy sequence converges. If we prove that it is not a Cauchy sequence, then it doesn't converge. Hence sigma un doesn't converge. So to prove that it is not a Cauchy sequence, I take S2n. What is S2n? 1 plus half 1 by 3 plus etc. 1 by n plus 1 by n plus 1 plus etc. 1 by n plus n. 2n. Therefore, S2n minus Sn is equal to 1 plus S2n minus Sn. 1 upon 1 n plus 1, 1 upon n plus 2 plus so on, 1 upon n plus n. N plus n. And it is greater than 1 upon 2n, 1 upon 2n, 1 upon 2n. I think these steps are clear here. 1 upon n plus 1 is greater than 1 upon n plus n. 1 upon n plus 2 is greater than 1 upon n plus n. For all values of n here, it is greater than. It is therefore, how many terms are there? N by 2n. It is half. Therefore, if epsilon is half, we cannot find out this any number m. What is Cauchy sequence? A sequence Sn is said to be a Cauchy sequence if for epsilon greater than 0 we can find out p, natural number, so that Sn minus Sm is less than epsilon for all nm greater than or equal to p. This is definition of Cauchy sequence. But now, if epsilon is half, we cannot find out any natural number p, so that Sn minus Sm is less than epsilon, less than half. Therefore, it is not a Cauchy sequence. What is that? Sn. Hence, Sn doesn't converge. Therefore, sigma un doesn't converge. So the result important. What is the result? If a series converges, sigma un converges, then limit un is 0. But converse is not true. What is the converse? If limit un is 0, then the sigma un need not converge. Go through the video, and always the first basic things are very important. You understand, try to understand all the things I explained. Definition of infinite series, definition of convergence of infinite series, and I explained by taking 3 examples. Then this result. You go through this, and I consider the topics one by one. Next topic, I consider some standard series. Okay, thank you.